Today we're going to be talking about proportions. We've talked about what it means for something to be proportional and when we say two equal ratios, but now we're going to take that one step further and we're going to solve proportions. And we are also going to talk about how we would use proportions in real life. So, to begin, are they proportional? There are three ways to test. We have already done these before in the past. I think it was 5.2 or 5.1, I'm sorry, we tested if they were proportional. You can use mental math, which is the jump across method that I refer to, where you multiply or divide simply straight across. You can simplify both ratios by simplifying the fractions or turning them into decimals, or lastly, cross multiplication. So if we were to look at these three examples, and I typically like to do the mental math if it works out nicely. Now, it doesn't always. So for example 1, I can get from a 1 to a 2 by multiplying by 2. So if I'm going to multiply by 2, I'm going to see if I could do the same thing on the bottom. Nope, that doesn't work. So this example, they are not equal. Example 2. Mental math doesn't work here. I can't jump from a 5 to a 2, so I can't use that method. So what I'm going to do is I'm actually going to use cross multiplication. 2 times 12 is 24. 5 times 5 is 25. Now these fractions may have been very, very close, given that our answers are very close, but they are not equal. They are not proportional. You need to understand that equal ratios is the same thing as proportional. I look at number 3. My first thought is to use mental math because I know 5 can go to 15 by dividing by 3. I'm sorry, I'm thinking opposite. Multiply by 3. I can multiply by 3. 2 can get to 6 by multiplying by 3. So therefore, these are proportional. So that's a little bit of review. Solving a proportional, slide 2 here. You should be following along in your notes if you're not. We're now going to solve. So we can use these same three methods. We can use cross multiplication will help us. It's going to be working a little bit differently. Mental math is the easiest when it works, in my opinion. Or you could just kind of think through it as far as simplifying it. So I'm going to work through this by using the jump across. So how do I get from 27 to 9? I get that by dividing by 3. So now whatever I do to the top, I'm going to do to the bottom. So I'm going to also divide 15 by 3, and that would get me an answer of 5. So for these to be equal, x would have to equal 5. Okay? Example 2. I will say jump across does not work here. So here's where cross multiplication happens. I'm going to multiply 15 times 4. And when I multiply 15 times 4, that gets me an answer of 60. Now, I can't do 6 times x and get anything, but I know they're going to be equal to each other. So I know 15 times 4 of 60 is going to be equal to 6 times x. So technically, what I would do next is divide by this 6, and that would get me our variable. So if I divide both sides by 6, I would get x is to be 10. Okay? So another way we could go about doing this is just remember you would do 15 times 4, and then you will divide by your third number that you haven't used yet. And this is why that happens. Example 3. Again, jump across doesn't work. I can't get from a 2 to a 5. So what do I have to do? Cross multiplication. I'm going to multiply 110 times 5. That's going to get me 550. I'm then going to do 550 divided by our last number left, divided by 2. And the reason why I do that is because I would get 550 equals 2 times m, and I would then divide by 2. So if I do 550 divided by 2, that gets me an answer of 275 for m. The next examples I'm about to do, they can be tricky because there's a little bit more involved with them. It's not just an x in the bottom or an x in the top. It has another operation involved with it. But we can still use either method, and I will show you how both of those work. I'm going to first start with the jump across. So how we get from 5 to 10 is multiplied by 2. So I know I'm going to have to multiply by 2 down here, and this whole answer is going to be what I get when I do 17 times 2. So 17 times 2 is 34. So 34 is what you get for x minus 4. Okay, this is equal to 34. So what is x if that whole thing has to be 34? Well, let's solve that equation. Let's add 4. Therefore, x would be 38. It's a little tricky, but remember, you're going to do the same thing to the top that you do to the bottom. And therefore, we know our answer for this whole spot has to be 34. So then I can kind of think backwards. So let's add 4, and that will give us our whole. The next one, I realize you can do jump across, but I'm going to show you a little bit differently. I'm going to do cross multiplication. I'm going to do 6 times 18. So when I do 6 times 18, that gets me an answer of 108. Now, that's going to be equal to whatever I get when I cross multiply this. Now, when you multiply, you're going to be doing 9 times x plus 3. Okay? You're multiplying 9 by that whole thing, not just the x. So you do have to distribute. So 108 equals 9x plus 27. Now I can solve a two-step equation. We're going to get rid of the 27 first. Now I realize this is more time consuming, but jump across doesn't always work. Cross multiplication always works. So 108 minus 27 is 81, and 81 equals 9x. I divide by 9, x equals 9, because 9 divided by 9 is 1, 81 divided by 9 is 9. So that is how you get your variable using cross multiplication. Again, this always works. This sometimes works with the jump across. Now let's do a real life scenario. Whoops. A shade of paint calls for 5 parts of red to 7 parts of blue. So I know I'm going to have 5 parts red. So if I'm going to make my ratio 5 parts red to 7 parts blue. If you mix 21 parts of blue, how many parts of red will you need? So however you set up your ratio, you need to be consistent. I like to use what I'm given and do top bottom. And I'll show you another way that you can do it. But we know that blue has to match up to blue. So I have to put 21 down here. And then our top is what we're going to solve for. So how many parts red do I need? We can use jump across here. So if I'm going to use the jump across, I get from 7 to 21 by multiplying by 3. So I'm going to do the same thing to my 5. I'm going to multiply by 3. What that means is I need 15 parts red. Now I said that's not the only way you could do it. I could set up, instead of red on top, blue on bottom, I could do 5 red and then the other unknown red equals, so that means I put the sample on top and then the big amount on the bottom. So I would do 7 blue to 21 blue. I prefer this method. Less mistakes will happen, but you can choose whichever way you want. Last one. It costs $96 to purchase 4 pairs of headphones. So if it costs $96 for 4 pairs of headphones, I'm going to abbreviate this with HP. How much would it cost to purchase 10 pairs of headphones? 10 pairs of headphones. So that's setting up my units exactly the same. Headphones, headphones, cost, cost. So this one, I cannot use jump across, so I have to use cross multiplication. So to do that, I would multiply 96 times 10 and get 960, and I divide by what's left, divided by 4. 960 divided by 4 gives us an answer of $240. And that is how you use proportions to solve real life problems.